TCP/IP. TCP/IP stands for Transmission Control Protocol/Internet Protocol. It is a set of rules, protocols that govern how data is transmitted over a network, especially the internet. Without TCP/IP, devices wouldn't be able to communicate with each other over the internet. It is the foundation of how the internet works and how data flows between computers and servers. When you send an email or browse the web, TCP/IP is working behind the scenes to ensure the data reaches its destination. Layers of the TCP/IP model. TCP/IP works through a layered architecture with each layer responsible for different aspects of communication. This layered approach allows flexibility as each layer handles specific tasks and can be upgraded or changed without affecting others. The layers: application layer, where applications like web browsers and email clients operate. Transport layer ensures reliable data transfer using protocols like TCP. Internet layer manages the routing of data across networks using protocols like IP. Network interface layer deals with the physical transmission of data over a network. IP, Internet Protocol. IP, Internet Protocol, is responsible for addressing and routing data packets across the network. It makes sure data reaches the correct destination based on the device's IP address. Every device on the internet has a unique IP address. Example 192.168.1.1 for a local network, or 8.8.8.8 for Google's public DNS server. IP ensures that data packets know where to go. Types of IPs. IPv4, the most common form but limited by the number of available IP addresses. Example 192.168.1.1. IPv6, a newer version to accommodate more devices with larger address space. Example output below. TCP, Transmission Control Protocol. TCP is a protocol in the transport layer that ensures reliable communication by making sure data arrives in the correct order and without errors. TCP breaks data into small packets and sends them to the destination. The destination device acknowledges receipt of each packet. TCP ensures data integrity, making it reliable for things like web browsing, file transfers, and emails where errors in data can be disruptive. How TCP/IP communicates. Data flow. Step 1. Data creation. A user clicks a link or sends an email. The application layer creates the data to send. Step 2. Transport layer. The data is broken down into smaller packets by TCP. Each packet is given a sequence number and checks for errors. Step 3. Internet layer. Each packet is wrapped with an IP header, which includes the destination IP address. IP handles the routing of the packets across networks. Step 4. Network interface layer. The data is transmitted over physical mediums like Ethernet or Wi-Fi to the destination device. Step 5. Data reception. Once the packets arrive at the destination, they are reassembled and sent to the application layer for the final use. Example, opening the website. Why TCP/IP is important. Universal standard. TCP/IP is the standard protocol suite used by all devices on the internet. It ensures that different devices, regardless of the manufacturer or operating system, can communicate with each other. Interoperability. Because TCP/IP is a universal standard, it makes the internet a globally connected network, allowing devices from anywhere to interact with each other. Scalability. TCP/IP allows the network to grow, accommodating millions of devices from small IoT devices to large data centers. Security and reliability. While TCP/IP doesn't have built-in security, it can work with security protocols like HTTPS, TLS to ensure data integrity and privacy during transmission. Real-world example of TCP/IP. When you visit a website, TCP/IP is working behind the scenes. Your browser application layer sends a request for the web page. TCP transport layer ensures the request is sent reliably, breaking into smaller packets. IP Internet layer makes sure the request is sent to the correct server using the server's IP address. The server processes the request, and the same process happens in reverse to send the web page data back to you. Key terms. Packet, a small chunk of data transmitted over a network. IP address, a unique identifier for devices on a network. Port number, a number used to identify specific applications or services. Example, HTTP uses port 80. Router, a device that forwards data packets between networks using IP addresses. Protocol, a set of rules for communication. Example, TCP/IP. Key points. TCP/IP is the protocol suite that allows devices to communicate over the internet, ensuring that data can be sent reliably and correctly. IP handles addressing and routing, while TCP ensures reliable data delivery. TCP/IP is crucial for everything from browsing the web to sending emails and transferring files. Without TCP/IP, devices wouldn't be able to send data to each other effectively, and the internet wouldn't function as we know it. Thanks for watching!